Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello, welcome back to This is Abhinav. Hello, welcome back to our channel. This is Abhinav, and today we are going to discuss about the new problem of the day, which is express as sum of power of natural numbers. So the problem today is quite a medium level problem. It's not much difficult, but it's a DP problem based on a dynamic program approach. First of all, let me know if I'm clearly audible and visible to you all, so that we can start. Just press one. Hi Ram Gopal. Hi Risit. हाय समवन चाइनीज हियर सर हमें जीएफजी का टी शर्ट चाहिए कैसे मिलेगा राम यू कैन लाइक जस्ट सॉल्व पीओडी रेगुलरली you can earn geek bits and based on that geek bits you can get geeks for geeks t-shirt. It's a very easy process, so you can just go for it. Okay, so guys, is it fine? Is it clear to everyone? Can we start with the problem? Great. So hello Nakaj, hello. So the problem today we are having here is something expressed as sum of power of natural numbers. Simple thing is that you have to tell the way how a number can be expressed as a term of natural number. Like there are multiple ways of expressing a number as a sum of natural number with the power x. That's the basic thing. I hope that everyone is better with the problem. Let's say they are giving n as 100 and x as 2. So they're asking how many number of ways are there such that n can be expressed as the power x of natural number. Just like you can see that 100 can be expressed as 10 to the power 2, like 10 to the power x, which is 2. 100 can also be expressed as 6 square plus 8 square. 100 can also be expressed as 1 square plus 3 square plus 4 square, 5 square, 7 square. So it's a difficult problem. I know it's a really difficult problem, and it's based on the dynamic programming approach. Okay, so let's discuss how we can solve this particular problem. Okay, so for this particular problem, we'll be having a dynamic programming approach. Okay, so guys, what we'll be having is we'll be having for every number from 0 to n, I will find that how, like, what are number of ways such that they can be expressed in the power of x. That's a very simple thing that we will do. Okay, so guys, what we will do, if I will ask or talk about let's say that there is a number y. Okay, let's say that there is a number j. Okay, let's say there is a number j, and we have to check that whether j can be expressed uh, in uh, in the terms of uh, some natural number to the power x, let's say I to the power x, okay, and sum of some that natural number, okay. So let's say, guys, I'm saying that there's a j, okay, we want j. So if there is a something called I, if there is a natural number I, okay, and I'm giving x to it, I'm giving x to it. Can I say key? Let's say that I'm having a function dp. So dp of j denotes number of ways j can be expressed in the terms of natural number to the power x. Okay, that is what dp is. So dp is basically the number of ways how it can be expressed. Okay, and I'm saying that this is something called I to the power j, which is I to the power x, which is given to us. I is a simple number. Okay, so can I say that dp of j is equal to dp of j is equal to, or I can say like this. I can say like this. Maybe it's quite confusing. Let me try to explain it in a different way. Let me try to explain it a different way. See, just assume it this way. Actually, it's a really difficult problem, and it's even difficult to explain also. Okay, but yeah, let me try to explain, and I will try to implement the problem. Uh, I will try to explain and implement simultaneously so that you can understand. Okay, so देखो basic thing क्या है कि let's say we have a j and we have a I to the power x, ठीक है. So like let's say I'm taking a natural number 1 to the power x plus natural number 2 to the power x plus natural number 3 to the power x. Let's say this is equal to j. Okay, this is equal to j. Can I say this thing? Okay. So what if we can, and let's say that this thing is equal to I. This thing equal to I means the sum of these things is equal to I, and I plus this n4 to the power x is j. Simple. So can I say that if there are 5 ways, there are 5 ways to implement this I or to express this I. So that 5 ways are also applicable with this j. That 5 ways are also applicable with this j. Why? Because in that 5 ways, I would just add this n4 to the power x, and that's all. And that's all. Or I will tell you one more approach. Let's say I'm saying that a is equal to 3 to the power x plus b. Simple. Okay. And I'm asking you that how many ways are there to express, how many ways are there to express a? So can I say the number of ways to express b? If I can find, number of ways to express b, so in every way, let's say to express b, there are 3 ways. A to the power like x, let's say I to the power x plus j to the power x. Second way is I to the power x plus k to the power x. Third way is uh, y to the power x plus L to the power x. These are the 3 ways. So can I say if this B has 3 ways to implement, to express, then this A also has 3 ways? Just add here 3 to the power x. If this B has 3 ways to express itself in the form of power x, so means A also has 3 ways to express itself. Exactly. And that is a simple logic that we are going to implement. Is it somehow clear? Tell me. Is it somehow clear? Okay, great. So guys, that's the basic approach how we do this particular problem. अब see, हम लोग क्या करेंगे, what we will do is that for every number from all the numbers from 0 to n, we will have the DP approach and we will try to find this particular solution. Okay, the solution is not much difficult, like it's not much complex, it's a simple solution. So first of all, what we will do, guys, we will take our DP array here, a vector in name DP. Okay, size will be n plus 1 and initially all the values are 0. Like initially I am assuming that the ways to express every number is 0. The ways to express a number is simple 0. Okay, this is a simple 0 base. Now the base case is that DP of 0 is 1. That's the base case. Why? Because like if you will see, if I have to express 0, so there's only one way to express 0, that is 0 to the power x. So I'm assuming that, by the way, they're asking natural numbers, so we even cannot express 0. But we are assuming it so that we can implement the thing. Okay. Now for all the values from 1 to n, for all the values from 1 to n, we will try to find its value. Okay. अब देखो, अब now what is I, why we are taking from 1 to n? There's a reason for it, guys. There's a reason why we are taking from 1 to n. Let's say, guys, that I have to find that how n can be expressed as a part of a power of natural number. So you can say n can be expressed, maybe have a to the power 1 to the power x, 2 to the power x, 3 to the power x, up to n to the power x. Like this value, this natural number value cannot be greater than n. Am I right? If you have to express n in terms of sum, so this n cannot be greater than n. It will be always less than this value. That is why we're having from 1 to n. So I'm assuming this I as the number that I will take among all the natural numbers. So that I will be, so I'm assuming this I as this natural number. Okay. I have to take I to the power x. I have to take I to the power x. Okay. So I will find simply the value of I to the power x using the power function. So let's say long, I will take a large long int. Okay. Let's say y is equal to power I comma x. This is nothing but it is the value of I to the power x. So I'm assuming it as I to the power x that we are considering it. Okay, and it can be a very large number, so I'm taking it in long end. Okay, great. Now this is what I'm assuming as y. So I'm assuming that okay, I'm expressing this n as I to the power x, or I can say y. But plus what? Plus n minus I to the power x. So देखो अब ये मैंने क्यों किया है? Why we are doing this is the DP function that we are doing. So what we will do that for all the n's from n till I, we will do. So this DP of j will represent number of ways how j can be expressed. So in this DP of j, what I will do is I will add. There's a reason for it, that if this y is, or I can say if j is greater than y. If j is greater than y, means the number that we are considering is greater than, or I can say equal to also. If it is greater than or equal to y, that means that we can use this y to express j. So j is a number that I have to express. Y is what? Y is I to the power x that we are taking to express that number, and the remaining part is j minus y. So the number of ways, just like I've told here, number of ways to express A is equal to the number of ways to express B. Similarly, to number of ways to express J will also contain a number of ways to express J minus Y. So if it is greater, means if J can be expressed in terms of Y. So what I will do, I will make dp of J, I will add in it dp of J minus Y. That's the basic thing that we will do. And that's all. And then at the last, this is how for all the j to be printed, at the last we will return the value of dp of 10. But they want us to find answer in modulo 10 power 9. So we will take here a value called mod 10 power 9 plus 7. And we will take the value mod everywhere. This is just like we do modular arithmetic. That's all. So if we will run this code, so the problem was quite complex as it was a dynamic programming problem, and it's a, like a really difficult dynamic programming problem. Okay, easy nahi hai. So that's the thing how we are simply implementing this particular approach. Okay, the simple way is that if we have to represent j using y, so number of ways to represent j will also include a number of ways to implement j minus y. That's the simple thing. It's something similar to we have done problems like count number of stairs. Okay, so it's something similar to that. Yeah, see, this outer loop is taking the values I which we are using. Like if I'm taking this I to the power x, that means that we'll be using this I to the power x to implement j. That's the first thing. Now this j loop is for the numbers of this dp. Means for all the numbers from I to n, we will count number of ways to express them. So if the value of y is less than j, that means j can be implemented using y. If j is like if y is less than equal to j, that means we can use y. Y means I to the power x. We can use y to express j. So if we can use y to express j, means if I can write j is equal to y plus like this something. So can I say that number of operations, the number of ways to express j can also include number of ways to express j minus y, and that is what we're adding. So in dp of j, we're also adding dp of j minus y. So means simply we are counting number of ways for j using y. If you are considering y as the part, you have to find. That's the basic thing. Let's say let me give you an example. Okay, let me give you an example. Let's say you are counting for 100 only. So for 100, I will say ki, in how many terms it can be expressed. So like when I is equal to 1, if I is equal to 1, I will check. So when I is 1, let's say x is 2. So if y will be I to the power x, which is 2. So means this is j. So means 100 minus, like it will be 1, sorry. 100 minus will be 99. Now I will check for the value of 99. In how many ways 99 can be expressed. But for 99 we haven't calculated. So again I will check for 99 minus this I, 98. And this is how it will go on. Then my I will become 2. This will become 4. Now I will check for 100 minus. So let's say when this value will become 8. So this will become 64. So when it will become 64, it will check for j minus y, which is 100 minus 64, 36. And for 36 also it will find that the value will be 1. So ultimately it will become, yeah, 64 plus 36 will be the answer. So if you will have a try and if you try to understand the solution, you will get, I know it's a tricky problem. I know it's quite difficult to be explained. Like even we don't have a basic test case to explain. Okay, test case are very, like DP problems are, and even in a tabulation form, it's very difficult. If you will even try the recursive form, it will be quite easier, but not efficient. Okay, so that's all for this particular video, guys. I know it's quite difficult problem, so please have a try. Yeah. The inner loop is from 9 to n to I actually, not 1. Okay, it is from n to I. The reason why it is from n to I is, first of all, as I told you, that the value of j should be greater than equal to y. By if I wanted, let's say I wanted to express 10 in terms of 2. So I can express, but I cannot express 2 in terms of x. So if I have to express j in terms of y, so y should be less than j, first of all. And what is y? Y is I to the power x. Y is I to the power x. So this this j value should also be at least greater than I, because y is I to the power x. Getting this, y is I to the power x. So if you have to express j in terms of y, so j should be greater than y, and at least it should be greater than I. I से बड़ा तो होना ही चाहिए. So it should be at least greater than I. If you want, you can make it 0 also. Then also it will work. But in all the cases, it will reject. This statement will reject it. So I'm starting from I only. Okay. And we are having this manner because we are having the top-down approach. Okay. It's a tabulation approach. So we are first finding for n, then using n minus 1, n minus 2, like that. So if you will try to figure it out, the dry run, you will get it. Okay. So that's all for this video, guys. Let's meet again tomorrow with the next problem of the day. Let me check the problem for today. It's the modify linked list. So it's some linked list problem. Okay. So great. Let's meet again tomorrow. Till then, happy coding. Bye bye. Take care. GFG कर लो. हो जाएगा.